Hello everyone, welcome back to Infinity Physics. In the last lecture, we had a discussion about uses of convex mirror, and for the different position of the object, we have obtained the image and also its nature and size. So in these lectures, we have obtained with the help of a ray diagram. But in all the cases, we don't need to draw the ray diagram. By just seeing the data, that is the distance of the image, the height of the image, we can easily determine the nature, and for that we need to learn Cartesian sign convention. And if you have not watched my previous video, please watch it and subscribe my channel. So Cartesian sign convention. So Cartesian means you are very familiar with Cartesian coordinate system, right? So simply that we will use. So here, and convention means it is simply for our convenience. The scientists have determined some rules, decided some rules, and that we have to follow when we are using the mirror formula, right? And that mirror formula we will we will derive in the next lecture. So for example, assume that there is a plane mirror, right? And in the plane mirror, when you are standing away at some distance away from the plane mirror, your image will be at the same distance but towards the opposite side, but your height remains same. So here you can see that if I consider this point as plane mirror as a origin, then you are standing towards the left and your image is towards the right. So here I can say the object distance, let's say object distance is u, so u is equals to -5, but image is on the other side, so we can say v is equals to, but at the same distance, so I have to write as a +5. See here minus and plus indicates that both are on the other side. But what if I have used here a concave mirror, right? Suppose I have placed at the center of curvature. So if I place it here and I get the image at the same center of curvature, right? But we get inverted image. So here u is equals to, it is -7, right? And v is equals to -7. So this indicates that the image and object are at the same side of the mirror. So by just seeing the data plus and minus sign, you can identify that the image, the nature of the image, either it is virtual erect or real inverted. Another example, suppose here height of the image is +5 and it is a plane mirror, so you will get the same height +5. So +5 +5, right, in height, right? Last time we have seen the distance. In this case we are measuring the height, and height we measure on the above the x-axis, that is on the y-axis, right? So height is +5 +5. So +5 means it indicates it's a real, it's a virtual and erect image, right? But suppose if I have used a concave mirror, so this is a concave mirror, and if I again I am placing at the origin, at the center of curvature, and I get the image like this, because when we placed object at center of curvature, we get the same we get the object at the center of curvature, and but it is inverted. So in this case the height is +5, and in this case also we will get height 5, but it is -5. So here height is -5 and here the object height is +5. So one is plus, another is minus, so we can clearly identify that the image is in the negative y direction, and negative y direction means it is inverted image. So by just seeing the plus and minus sign, we can easily identify whether the image is real, inverted or virtual erect. So in case of a plane mirror, we have seen that we have obtained is virtual and erect, but in case of a concave mirror, we have obtained the image is real and inverted. So the sign convention makes the study very easy. So let's see what are the rules, what are the convention that we have to follow. So here we have a concave mirror. Instead of using concave mirror, you can also use convex mirror. Sign convention for both the mirror remains same. So here we have a concave mirror which is placed at the origin. This is the origin, right? And this is the y-axis and this is our x-axis. So the following sign convention is used for measuring various distance. So first convention, these are strict conventions, we have to follow it. Object is always placed to the left of the mirror, that is we have to keep our reflecting surface this side, right? This is the reflecting surface. If I am placing convex mirror, then I have to place it like this. So this is the reflecting surface and we have to place our object at the left of the mirror, or we can say of the origin. So if we are placing the object at the left of the origin, then our object distance is always this side. So our object distance is always negative. So you just remember the convention. First we have to place at the left of the mirror. All the distances are measured from the pole. That is this pole is our origin. So if I am placing the object at this particular position, then I have to measure the distance from the pole. I cannot measure from any point in between, that is from the focus or center of curvature, anywhere. I have to measure it from the origin, that is how much exactly it is far from the center. Now let's see the another convention. The distances measured towards the left of the origin are considered negative. That is, if I placed my object here, then towards the left I have to consider as a negative distances. That is, it is see minus 7 centimeter away. So distances towards the left of the origin, right, means this side we have to consider as a negative. And distances towards the right of the origin, that is, if I placed a mirror here and I am placing object in front of the mirror like this, and if I may get image here, then this distance is towards the right of the origin, and towards the right of the origin we have to consider the distances as positive. Similarly, height measured upwards, that is above, right, upwards and perpendicular to the principal axis are considered positive. That is, whatever the height we are taking above the origin, right, that we have to consider positive. That is, if the height of object is this, then it is falling in the positive y-axis, right? Its distance, see, distance we have to measure in negative, that is on the x-axis, right? All the distances we have to measure in x-axis, but height we have to measure on the y-axis. So here object is standing like this. So if I connect this here, I will get the height in the positive y-axis. Hence height measured upwards and perpendicular to the principal axis are considered as positive. That is this perpendicular, right? This height we have to measure. And height measured downward and perpendicular to the principal axis are considered negative. Suppose I have placed here a concave mirror. So this is a concave mirror here also, and if I am placing object here and I am getting an image here, so here I am getting it in the negative, its height is in the negative y-axis. So I have to consider the height as a negative. Remember this, all the conventions that are very useful in determining the nature of the image. Please note it down. So points to be remembered, and these are very important point. See the focal length, right? This is our concave mirror. See, it is curved from here, right? And this is our convex mirror, that is curved outward. The focal length of concave mirror is always negative, because if you see the concave mirror, its focal length is always this side, right? You remember, this is our concave mirror and this is our focus and this is our center of curvature. So the parallel rays will get focused here at this point, hence we call it a principal focus, and this is our pole. So the distance from the pole to the principal focus, this distance we consider as a focal length. So in case of a concave mirror, the focal length falls towards the left of the origin. Also the center of curvature falls towards the left of the origin. So that's why we have to consider the focal length of concave mirror negative. Radius of curvature always negative, because it is also falling here. See, this is the radius of curvature. Similarly, object distance. See here, these red lines are all the object placed at the different distances from the mirror. So all these distances we have to consider negative because they are falling towards the left of the mirror, and this situation is similar for the convex mirror also, because in all the mirror or lens we have to place our object towards the left, and all the distances towards the left of the origin are considered as negative. And image distance. So image distance for concave mirror, it is why I have make star, because for the position, that is when we are placing our object between from infinity to here, from infinity to focus, we are getting the image real and inverted like this. So in this case the image distance is always v is equals to negative. But in the sixth case, remember the sixth case of a concave mirror, so when we are placing the object between the center of curvature and pole, we get image here. So in this case considered, because in this case the image is towards the right of the origin, so in that case the image distance is positive. So here you can see that here for 7, 8 and 9, here we are getting the image 7, 8 and 9. So in this case the image distances are positive. But here for the other cases 1 to 6, 1, 2, 3, 4, 5, 6, you can see the images are here. These blue lines are images 1, 2, 3. So all these images are towards the left of the origin. So in that case we have to consider the image distance is negative. Right. So remember this. For case 1 to 5, the image distance is negative in case of a concave mirror, and for case 6, the image distance, that is in the case of a concave mirror, we have discussed about 6 cases, right? So in the if the object is placed anywhere between pole and pole and focus, the image is obtained behind the mirror. So that's why the image distance is positive for all the cases between pole and focus. Now here in case of a convex mirror, the focal length is positive. Why it is positive? Because the convex mirror looks like this. It's look like this, right? So if the rays are coming parallel, this all rays get diverged, and when these rays are traced back, we obtain a focus here. So if I consider this as the origin, then my focus is towards the right of the origin, and towards the right we have to consider it as a positive. Similarly, object we have to always place towards the right or left of the origin. So here this all are the object distance, and you can see that for the various object distances we get our image towards the right of the origin, right? So we will get always object image towards the right of the origin. Hence we have to consider the image distance positive in all the cases of convex mirror. Similarly, if height is given, so we are placing the object vertically upright, we are placing the object like this. So height of the object in all the cases we have to consider positive. So if you have any doubt, please comment, and if you like my video, please subscribe and share with your friends. Have a nice day.